So these are some of the non-cognitive skills or performance character skills that we're going to be fostering this summer. But what will the 3 weeks look like, right? And the program is very loosely modeled after a kind of a truncated day at St. Ambrose, interspersed with some of the things that they might do at like Summer Camp Gray or something like College for Kids. So one of the things that we'll ask you and your child to fill out is an inventory of the students or the child's non-cognitive skills. Are you someone who procrastinates, for example? If you don't want to procrastinate, the first thing to do is to be aware that you do. And so we'll look at that, and then we'll do the same thing at the end of the program. There's also a written assessment that we'll write and an action plan that we'll produce that your child can take into the school year in September of 2015 when that gets underway. So what a day looks like at the St. Ambrose Academy Summer Academic Skills Workshop, and this is just a very sort of rough view, is the student will arrive at around 8:15. They'll get settled in, and in terms of the class that I'll be teaching for the older students, those students who will be entering 8th grade and 9th grade, we're going to get them excited right away with a demonstration of something. So for me, it'll either be something involving chemistry or I'll cook something. And we'll prepare that real quickly. Then we'll go to instruction, and we'll look at the science behind what I just did, what I just prepared. And so that's where some of the book learning is. We'll take a break, and then we'll do the praxis or the practicum, where the students will then come together and take those principles that they learned in the book, whether it be principles of physics or chemistry or math and biology, and they'll apply them in the kitchen. We'll have a lunch, and then we'll have a short segment in the very early afternoon devoted to non-cognitive skills, either a motivational speaker or some exercise that's designed to help them work with these non-cognitive skills. Now, specifically, with regard to food science and history, I wanted to talk a little bit about content. This is, again, because we are focusing on skills, content isn't really the center of this, but nevertheless, it's important, and we want your student to learn how to do things. Ideally, I want the students to come from this, developing these academic skills, but also knowing something about how to cook a meal. So it's just amazing how interdisciplinary something like cooking can be. First thing, of course, we have to talk about is safety. We're going to learn how to operate a fire extinguisher. We're going to learn how to handle hot items safely. We'll learn, should this happen, this will not happen, but should it happen, how to treat a burn, how to treat a cut, how to handle a knife safely, how to handle food safely, how to preserve food safely. And when I say preserve, it could be as simple as putting some, how do you put hot items in the refrigerator, or do you let them cool down first before you put them in the refrigerator, and why? And of course, we have to learn, since it's cooking, the importance of personal hygiene. That's safety. But the science behind cooking, right? Just the scientific method. We'll see how just cooking on its own isn't science, right? It's an activity, and it's a great activity. It becomes science when we start to compare things, when we start to introduce the scientific method, when we include variables and controls and constants And we'll do that. We'll do that right away with our pancake exercise, right? Taking different groups, throwing together a pancake batter. What is going to be our control? What will be our independent variable? And then, of course, how will we test it? How will we test our hypothesis? Well, we'll eat it. So in the process also, students will learn the distinction between inductive and deductive reasoning. Of course, when it comes to food, we're talking about chemistry, right? Absolutely. Right? So we'll learn about acids and bases. We'll learn about solutions and mixtures, so emulsions like mayonnaise. We'll learn about gels like jelly. We'll learn about foams like bread. We'll learn about the 4 basic food molecules. Water, a lot to learn about water, really. Lipids, fat. Carbohydrates, and proteins. We'll learn about chemical bonds. We'll learn about carbonation. We'll learn about phenols, what makes things smell so nice and taste so good. There's physics in cooking, right? Cooking, almost by definition, is, well, almost thermodynamics. So we'll learn about heat through conduction. We'll learn about heat through convection. We'll learn about heat through, well, radiation. We do have a microwave, so we'll have some of that. We'll learn about calories, how we find energy in food. We'll also learn about the physics of forces, especially shearing. Right? So that's what using a knife is. It's shearing force. We'll learn about shearing through whisking. Great example of physics there. And then, of course, we'll learn about biology. We'll learn about human physiology. How do we taste? Where do we taste? How does taste work? How does smell work? How does digestion work? What are allergies? Where do they come from? Why are we allergic to things? Why should we be concerned? We'll learn about organisms, of course, pathogens. Right? This is the whole safety theme. We'll learn about molds and how they can be our enemy and our friend when it comes to cooking. We'll learn about bacteria. We'll learn about plants, eggs, fish, and animal meats. Of course, cooking will involve mathematics. So there's conversions, there's ratios, there's volume. We'll learn about measurements. We'll learn about history and economics. A little bit about the history of eating. Focus a little bit on some of the great Catholic practices involved in eating. Some really fascinating histories there. And then we'll also talk about how does food get from the farm to the table. But ultimately, we'll be working on these strict sort of academic themes in an applied way. This is applied science. This is applied humanities. So students will learn about being a farmer, how agriculture works. We're going to visit a farm, one of our field trips. Students will learn about being a chef, an occupation, or being a cook, or being even a dishwasher. We're going to tour a restaurant. Students will learn knife skills, how to sharpen a knife, how that works. Learn how to cut properly and safely, how to cut an onion. Everybody needs to know how to cut an onion. And of course, we'll learn about cooking, not just pancakes, but bread. We'll make several of the French mother sauces. That sounds awfully fancy and elevated, but it's really not. Some of the great French cooking is actually what I think of as French soul food. It's just classic cooking. Students will learn how to make marshmallows, how to make jelly, and we'll learn how to improvise, because when we go on our farm tour, we don't know what we're going to get, but we'll have some things and we'll bring them back and we're going to cook them. So those are that's sort of the content of the cooking part of the Summer Academic Skills workshop, which again is also going to help help you, the student, you the parent of a child, develop these non-cognitive skills that are so essential for success. But this is just again for the 8th and the 9th grader. So what I'd like to do now is turn it over to St. Ambrose Academy's resident naturalist, Andy Galvin, who is going to be doing something a little different this year. Last year Andy did birding, but now he's going to, I call it dendrology, but that just doesn't sound right. I think you're going to be doing something maybe a little more specific than that. So.